Now let's talk about groups 3 through 12. All of these are considered to be transition metals. These can lose electrons from any of their inner energy levels, and they can form multiple different ions. So some of them form anions as well as cations. Some of them can have a -1 charge or a +1 charge, a -3 charge or a +2. They vary a lot. Sometimes you can even find a periodic table listed online. There is an interactive one. If you Google periodic table, it'll be the very first one that pops up. That one is very helpful, and it'll tell you all the different ions it can be. And that would be helpful if we're doing anything with transition metals, to be able to just have that resource. As we move through, we are going to color all of these green. So looking at the periodic table, it is going to be all of these in the middle here. So all of these are your transition metals. They vary in ions, and they are the one exception to the rule of losing electrons from their valence shell. Transition metals are very tricky and very complicated. We will get used to working with them as we do chemical bonding. Now let's talk about the inner transition, is what we call them, or the lanthanides and actinides. The reason that these are different is because we call these the rare earth metals. Most of these don't occur in nature. The last truly occurring element in this group is uranium, and the rest are made in labs. A lot of these are radioactive when you look at them. Uranium, when you hear uranium, you're hearing radioactive generally, because when we talk about like Chernobyl, we're talking about what happened with uranium, and the isotope was 238. So on your periodic table, we are going to color these brown. Again, this is the area that is lifted out of the periodic table. I don't have a brown, so I'm going to color them a nice light blue. You can make any notes that you want to help you make different connections with this periodic table. Group 17. These are what we like to call the halogens. These have 7 electrons in their valence shell. They form -1 ions, or what we like to call anions, and they are very reactive. They bond with metals to form salts, and they exist in nature bonded as diatomics. Remember that little 7 we made? Almost every single one of the elements that we included in the 7 are in this group. So we are going to color these orange. It's going to be these ones right here. These ones, you can write that they form a -1 ion to, again, help you kind of click that, hey, these prefer to gain an electron, which causes them to be a -1. The last group, these are noble gases. They have 8 electrons in their valence shell, which means they are happy atoms. They don't want any more electrons. They don't want to give up electrons, because they are pretty chemically unreactive, and they're stable. Helium, we put that in our balloons every day and have no issues with it. Neon signs, you see those around all the time. These exist as gases, and they're what we like to call inert gases. which means they don't react with the air, they don't react with water, they keep to themselves and mind their own business. We are going to color these purple. So it's everything as you're moving down the very last column. The note that you could write here is that you could write there stable or do not bond or +0 -0. Whatever you want to write to help you click that these do not like to react if they don't have to. Now let's talk about hydrogen. Hydrogen is all by itself, and it is the most abundant element in the universe. Hydrogen only has one electron and usually shares its bond. So it doesn't typically give up its electron or gain another electron. It likes to share it with other elements. It is one of those diatomic that we included in the 7, and it can have a +1 charge. It can either give an electron or it can have a -1 charge. It can take in an electron as well. We are not going to color this on the periodic table. You are just going to leave it with the box around it, and that's it. So right now your periodic table should kind of look something like this. And you kind of notice that all of this blank space here that we don't have a color in, well, there's nothing too typically specific about them except the fact that they are nonmetals. So you can go ahead and color these in with a different color. It can be any color you want as long as it's not one you already have, because these don't really fit the characteristics of everything else on the periodic table. They're just nonmetals. The one thing I will note is that this column right here likes to be a -2 column. That you can write to help you. So this concludes the lesson for today. Now you should have a nicely colored periodic table with a legend. This will be a nice tool to have for the rest of this class and in the future. I hope you enjoyed this lesson and have a great day.